We see a major transformation of medicine from an art into a data science. When we think of big data medicine, it's really the synergy of the advantages of the traditional physician-centered medical system and the computer-based system. Where these two come together, you can integrate an understanding for the patient on a personal level with a full understanding of the molecular mechanisms on the data level.
One of the important things about Blueprint, though, is it's very complex data. It's not just a lot of data, but there are a lot of ways that you can slice it up, lots of different cell types, lots of different assays. So it's big data, but it's also complicated. When it comes to big data, having more computers doesn't necessarily make things better. It might enable you to do what you're doing more quickly, but it doesn't sort of resolve some of the fundamental problems, which is when you have very complex data, you have to understand a lot about where it came from and what it is in order to be able to answer questions about it. So one of the key things that we did is making sure we have proper ontology terms, so sort of a proper dictionary to say what a particular sample is, what blood cell type it is, what disease it is, and that's about being specific. So when someone comes back in 5 years' time and looks, they know exactly what we had, rather than it being a term that might have multiple meanings and they don't know.
We have to balance the risk of data sharing, and there are some risks that people have raised on sharing of genetic data. North America, there's concerns about your employers, your insurance company getting knowledge of your genetic data. The same type of risk may relate to epigenetic data. We have to convey the information to the participants that we depend on doing our studies, that there are some risks related to this vast amount of data that we produce from each of the samples that are given to us, but it's in the benefit of mankind, let's say.